3,000 feet beneath the surface of the Pacific Ocean, where sunlight has never reached and the pressure could crush a human skull like an eggshell, something drifts through the endless night. Its eyes glow crimson in the beam of a submarine's lights. 8 webbed arms spread like a funeral shroud, lined with pale spines that catch the faint bioluminescence drifting through the water. This is Vampyroteuthis infernalis, the vampire squid from hell. And despite its demonic name, it harbors one of the ocean's most profound mysteries. How has this ancient creature survived unchanged for over 160 million years while entire worlds of life rose and fell around it? The story begins not in today's oceans, but in a time when dinosaurs ruled the earth and the seas teemed with nightmares beyond imagination. During the Middle Jurassic period, 165 million years ago, the ancestors of the vampire squid hunted in waters that looked nothing like the modern deep sea. These ancient vampyromorphs were fierce predators with powerful muscular bodies, strong suckers on all 8 arms, and 2 arms twice as long as the others, built for seizing prey with devastating efficiency. Fossils discovered in the limestone quarries of La Vault-Sorone in France reveal creatures equipped with ink sacs and luminous organs, combining defensive strategies never before seen together in the fossil record. One species, Vampyroteuthis atramentum, meaning fleeing vampire, prowled the twilight zones of Jurassic seas, using bioluminescence to communicate and ink to escape from the massive marine reptiles that ruled those ancient waters. But then came the Great Dying. The Cretaceous extinction event that ended the reign of dinosaurs also decimated marine life, whiting out countless species of cephalopods and forcing survivors into new evolutionary paths. While most vampyromorphs vanished into extinction, one lineage made a choice that would save it: retreat into the abyss. During the Oligocene epoch, between 23 and 34 million years ago, the ancestors of modern vampire squids were already living in deep, oxygen-poor waters, adapting to conditions so extreme that few predators could follow. The timing was perfect. As oxygen minimum zones expanded in the world's oceans, these creatures found sanctuary in a realm most animals couldn't survive. While their cousins evolved into agile squids and intelligent octopuses we know today, the vampire squid chose a different path. It stopped changing. It became a living fossil, preserving in its body the blueprint of an ancient world. The first humans to glimpse this creature didn't know what they had found. In 1898, a German zoologist named Carl Chun led the Valdivia expedition, determined to prove that life could exist in the crushing darkness below 300 fathoms, a depth where scientists believed only death and emptiness reigned. The research vessel Valdivia traced the coast of Africa, rounded the Cape of Good Hope, and pushed into the Indian and Antarctic Oceans, dragging nets through regions no human had ever sampled. When those nets surfaced, they carried creatures that seemed pulled from fever dreams: gelatinous bodies, enormous eyes, skin the color of dried blood. Chun initially described the specimens as octopuses in 1903, but as he studied them further, he realized these animals defied classification. They were neither squid nor octopus, but something older, stranger, more fundamental. He named them Vampyroteuthis infernalis, inspired not by feeding habits, but by their dark color and cloak-like webbing that gave them the appearance of gothic specters rising from the ocean floor. For decades, these specimens sat in museums, preserved in jars, their secrets locked away. No one could observe them in life. No one understood where they lived or what they ate or how they survived. The vampire squid became a legend whispered among marine biologists, a ghost from the deep that appeared only as corpses hauled up in nets, their delicate bodies mangled by the violence of the ascent. Then came the revolution of deep-sea exploration. In the late 20th century, as remotely operated vehicles equipped with high-definition cameras began descending into the abyss, scientists finally witnessed the vampire squid in its natural habitat. What they discovered shattered every assumption. The vampire squid inhabits the oxygen minimum layer, typically at depths between 600 and 900 meters, though some venture as deep as 3,000 meters, nearly 2 miles beneath the surface. This is a world defined by extremes. The water temperature hovers between 2 and 6 degrees Celsius, just above freezing. The pressure reaches 80 times that of sea level, enough to compress gases and slow chemical reactions to a crawl. But the most striking feature of this realm is the oxygen content. Levels drop to around 0.2 milliliters per liter, so low that most creatures would suffocate within minutes. Yet the vampire squid thrives here, its blood rich with hemocyanin, a copper-based molecule that extracts oxygen with extraordinary efficiency from water where there is almost none to extract. The appearance of this creature is simultaneously beautiful and unnerving. Imagine an animal the size and shape of a football, its gelatinous body shifting between velvety jet black and pale reddish hues depending on the angle of light. A webbing of skin connects 8 arms, each lined with rows of fleshy spines called cirri that wave gently in the current like the fingers of a ghost reaching through water. The eyes are what capture you first, proportionally the largest eyes of any animal on Earth, enormous orbs that appear red or blue depending how light strikes them, each one nearly as large as a human eye on a body smaller than a loaf of bread. These eyes can detect the faintest traces of bioluminescence across vast distances, allowing the creature to monitor an enormous volume of water for threats, prey, and potential mates in a realm where vision seems impossible. 2 small fins extend from the body like rounded ears, beating in gentle pulses to propel the squid through the darkness. But the most remarkable features are the retractile filaments, 2 long thread-like appendages that emerge between the first pairs of arms. These filaments can extend up to 8 times the length of the squid's body, reaching out into the void like fishing lines cast into an infinite sea. For over a century, scientists puzzled over their purpose. Were they sensory organs, weapons, lures? The answer, when it finally came, revealed something no one predicted about this so-called vampire squid. The breakthrough came through painstaking observations by researchers at the Monterey Bay Aquarium Research Institute. Using remotely operated vehicles equipped with high-definition cameras, scientists documented over 23 hours of footage showing vampire squids drifting motionless with one filament extended, suspended in the water column like living kites. Slowly, over hours, tiny particles would accumulate on the filament's sticky surface, fragments of dead plankton, discarded mucus structures from other animals, fecal pellets from creatures living in the waters above, marine snow, the detritus of the ocean. When enough material had gathered, the squid would retract the filament and scrape the accumulated debris into its mouth using its arms, packaging the particles in mucus to form small food balls. This discovery revolutionized our understanding of deep-sea ecosystems. Unlike its predatory relatives, the hunting squids and octopuses that stalk living prey, the vampire squid is a scavenger, a garbage collector of the abyss. It feeds on the remains of gelatinous zooplankton, crustacean fragments, diatoms, and the fecal pellets of other organisms. This lifestyle, while seemingly inglorious, is brilliantly adapted to its environment. Active hunting requires energy, speed, strong muscles, all luxuries that the oxygen-starved deep sea cannot afford. By becoming a detritivore, the vampire squid reduced its metabolic needs to an absolute minimum. It can drift for hours without moving, its filaments possibly collecting food while it conserves every precious molecule of oxygen. This strategy proved so successful that the vampire squid now plays a crucial role in the biological carbon pump, helping to lock away carbon from the surface world and bury it in the ocean's depths, regulating Earth's climate in ways we're only beginning to understand. But surviving on falling detritus is only part of the challenge. In the oxygen minimum zone, predators are few, but they are patient and deadly. Deep-sea fish like giant grenadiers and deep-diving mammals such as whales and sea lions occasionally hunt in these waters, and when they do, the vampire squid must rely on one of nature's most spectacular defensive displays. When threatened, it doesn't flee, it can't, with muscles weakened by low oxygen. Instead, it performs a transformation that seems like magic. First, the squid curls its arms upward and outward, wrapping them around its body, turning itself inside out. The webbing between its arms, normally folded inward, now faces outward like a cloak, heavily pigmented to conceal the squid's body. The cirri, previously hidden, now project outward like spines, making the creature appear larger and more dangerous.
In this posture, two large photophores near the fins glow with intense blue light, slowly narrowing to simulate the squid moving away into the distance, confusing any predator trying to judge distance and position. If this theatrical display fails to deter the threat, the vampire squid deploys its final defense. It releases a cloud of bioluminescent mucus. Unlike its shallow water cousins that expel black ink, the vampire squid expels a colorless substance containing particles of light-producing material, creating a constellation of twinkling lights that hang in the water like scattered stars. The predator, confronted with dozens of glowing points in all directions, loses track of which light represents the squid itself. In that moment of confusion, the vampire squid performs a rapid escape, capable of reaching speeds around 2 body lengths per second with an acceleration time of 5 seconds, though its stamina remains limited.
This entire defensive repertoire, the inside-out transformation, the simulated retreat, the glowing mucus cloud, represents one of the most sophisticated anti-predator strategies in the animal kingdom, evolved and perfected over hundreds of millions of years. The fact that it relies entirely on deception rather than speed or strength speaks to the fundamental challenge of life in the deep. Energy is scarce, oxygen is limited, and survival belongs to those who think rather than fight.